Hello everyone, welcome to the study of ODE of second order linear with constant coefficient. You are given second derivative of y with respect to x minus 10 dy dx plus 25y is equal to 0. So we are going to seek our solution of this form. So you can call this equation 1 and this the other one 2. We are going to seek equation of the form y is equal to c1 exponential mx plus c2x exponential mx. Then we are going to let our y to be equal to exponential mx. Then you differentiate this once with respect to x, which will give you m exponential mx. Then you differentiate it again, y double prime, to give us m squared exponential mx. You can call this equation 3. And the next step is you substitute 3 in 1 above. So you are going to do exactly that, whereby you will get m squared exponential mx minus 10 here. We have 10 minus 10m exponential mx plus 25 exponential mx, which is equal to 0. We factor exponential mx, which is common, to be left with m squared minus 10m plus 25, which is equal to 0. Now, exponential power any number can never be equal to 0. So exponential power mx is not equal to 0. What does that mean? It means whatever is in the bracket is the one which is equal to 0. So m squared minus 10m plus 25 is equal to 0. So this is a quadratic equation whose product is 25 and the sum is equal to negative 10. So we come up with two numbers, 25. You have 5 and 5. So 5 times 5 is 25. Negative 5 times negative 5 is 25, and negative 5 plus negative 5 is negative 10. So we factorize our quadratic equation and it will be m minus 5 bracket m minus 5, which is equal to 0, meaning that our m1 is equal to m2, which is equal to 5, which is equal to 5. Now, then from our equation 2, we end y is equal to c1 exponential mx plus c2x exponential mx. So we substitute the value of m, which is equal to c1 exponential 5x plus c2 exponential 5x. So that is what we have. The next thing which I want us to do is to check whether our working is correct, whereby we have now y single prime is equal to 5 c1 exponential 5x. Differentiating this equation once plus, when you differentiate here, there is x here, there is x there. So this is c2x exponential that. So you will get c2 exponential 5x plus 5 c2x exponential 5x. Here you have 5 and sorry, there is none which we can group there, so you leave it at that level. Then next we have y double prime, which is equal to, this will give you 25 c1 exponential 5x plus 5 c2 exponential 5x plus 5 c2 exponential 5x plus 25 c2x exponential 5x. This can be simplified to give you the following: 25 c1 exponential 5x plus, you have 5 and 5, which will give you 10 c2 exponential 5x plus 25 c2x exponential 5x. Now our given ODE is y double prime minus 10y single prime plus 25y is equal to 0. So we substitute what we have obtained above to see whether our equation holds. So we have 25 c1 exponential 5x plus 10 c2 exponential 5x plus 25 c2x exponential 5x. The other one is minus here. So you have negative 10 times 5 c1, which will give you negative 50 c1 exponential 5x. Then you have negative 10 multiplied by c2, which will give you negative 10 c2 exponential 5x. Negative 10 times 5, the one which is here, c2x will give you negative 50 c2x exponential 5x plus finally 25 c1 exponential 5x plus 25 c2x exponential 5x. So you take, so you have 25 here, so you can take that plus 25, that is 50, the one with the c1. Here you have minus c1, 50 c1, so there now you are going to get so the first thing we are getting there is 0 plus, we go to the one with 10 c2, so you have 10 c2, you mark that, minus this other 10 c2, 10, so 10 c2 minus 10 c2 will give you 0. Next, plus you have 25 c2x, and this other one here, 25 and 25 will give you 50. 50 minus 50 will give you 0, which is equal to 0. Meaning that now, when we have our own d as y double prime minus 10y single prime plus 25y, the result is equal to 0. And our solution, we have found it to be y is equal to c1 exponential 5x plus c2x exponential 5x. So this is the auxiliary solution of this given first order linear difference equation with the constant coefficient, whereby the roots are real and repeated. For the case of the root which are real and distinct, check in my YouTube channel so that we may learn together. Bye bye. See you in the next video.